This is Math 8, Section 6. I'm going to be talking about understanding linear and nonlinear functions. So something really important to understand is the rate of change. And when we have graphs in the past, we've talked a lot about the rate and representing it as slope. So we're going to make our little comparison here of what we've learned. We've compared it to. So when we do rate of change, it's going to be equal to the change in output values in values. And this is important to note, and it compares to what we've learned. Slope is y2 minus y1 over x2 minus x1. So this is really just the change in y, output values. X is really the change in input values. So when we talk about slope in lines, it's similar. We just state it differently for a function. For example, the rate of this graph here is always the output over the input, output over input, output over input, output over input, output over input, and each time it is equal to the same thing. So, for example, the change is 2 and the change is 6. So the change in output values was 6, the change in input values was 2, so that gives us 3. Change 2, that gives us 3. And it's equal throughout. That's going to tell us that it's a function. So if we can represent this as an output value like 3 minus 1, input values like 18 minus 12, those are the first two examples on the graph in the book, that's going to equal 3 over 2, 6 over 2. Let me rewrite this. 18 minus 12 or 3 minus 1 over 2 equals 3. And rate of change. Another example, and hopefully it makes a little more sense. So if we try it in one where we have x, y, every time you go up by different values, that's okay, as we go up here by +1, +2, and so on and so on. Down here, we also go up by different values each time, and it can still be a function. So notice this one is actually decreasing by 6, decreases by 12, and so on and so on. It could still be a function, change -6 over 1, which is equal to -6, same as -12 over 2, -6. Because those are the same, check, it is a function. If we try this again, and our values 1, 2, 4, and 1, 4, 16, plus 1, plus 2, plus 4, and plus 12. Well, we'll try this. So the difference here is 4 over 1, which equals 4. The difference here is 12 over, this would be 3. Is 3. The difference here is 12 over 2, which equals 6. So notice they're different, so it's not a linear function. So it is a linear function when rate is equal. Not a linear function when rate is different. So those are two important things to remember. Okay, let's try this in an example. Example 7. It gives us a scenario, the weight of turkey versus the time that it actually takes to cook it. So we have X pounds, Y time. If we have 10 and 15 pounds, 3.0 and 3.5 pounds, 20 and 4.0 pounds. Each time here, plus 5, plus 5, plus 0.5, plus 0.5, Well, we can calculate these and see that 5 over 5 equals 0.1. Again, it's 5 over 5 equal to 0.1. And I'm at 0.5 over 5 equal to 0. So because these are equal, check, it is a linear function. Go ahead and try this on guided practice 1 and 2. Now we're going to identify a linear function from our graph. And basically a linear function on a graph is our formula, y equals mx plus b. Can it be put into this formula? And is it a straight line? It's also linear. And if there is a constant rate or slope which makes it a line, so for example, a straight line has a constant slope, not a slope that begins shallow and gets steeper. So it's this, not that. That would make linear. So in order to tell if one has a constant slope, you just try 2 different points. So for example here, the slope between these 2 points, we test the change in rise is 3, the change in run is 1, so it's -3. Here, the change in rise is 3, run is 1, so it's -3. When it's the same, it is a linear function. Let's try that in example 8. So explain why the relationship between the 2 variables, a and s, is a function. So we're going to explain why it is a function. The relation between the 2 variables, a and s, is a function because from the graph, each input is assigned exactly 1 output. Function because passes the vertical line test, basically. And then we can tell whether the rate of change is constant by graphing between 2 separate points. So between the first 2 points, 0, 0, and 3, 9, m equals 1, and y1 and x1, x2 minus x1 equals 3. So then let's tell between the next 2 points, 3, 9, 6, 36, m equals 36 minus 9, and 6 minus 3, which equals 27 over 3, which equals 9. So they are different, not linear function. From the graph tell, well, the graph is not a straight line. It does not pass all of these things up here to become a linear function. Now try guided practice 3 and 4. Okay, now we're going to use some graphs to describe the functions. So increasing is when decreasing is when it goes down. So pretty easy. We can have in decrease. Remember, m is positive when it increases, m is negative decreases. So you can remember by this. Let's try it in an example. Kayla wants to buy some grapes from a fruit stand. Each pound of grapes costs the same amount. The amount of money she pays, y dollars, is a function of the weight of grapes she pays, x dollars. So give the least possible input value that makes sense for the function. Give the corresponding value. Tell whether the function is increasing or decreasing. So the smallest amount y is nothing. So 0, 0. Smallest possible amount. Then tell whether it's increasing or decreasing. Well, the total amount she paid would have to go up a lot more grapes. So it would be increasing. And if we were to draw this in a graph, kind of like this, it would start at 0, 0, and it would increase. We don't know the exact, we just know that it goes up like this. So try that on guided practice 5. And if you look at the hands-on, it is basically to draw graphs with different intercepts. So it's just a little practice with that.